In the archives of the Swedish Army, a strange number slips by: 106. Not a single combat vehicle under this index has survived. Not a full-length photograph, not a single specimen on a pedestal, not a line in the official register of accepted equipment. Only mentions in specialized armored vehicle catalogues, where next to this number, one and the same note invariably stands: the project was not implemented. The confusion is intensified by the fact that in museum archives there is a photograph with a caption pointing specifically to this number, and it features a completely different machine, the legendary Swedish turretless tank, famous worldwide for its design.
On this tank, the 105mm gun is rigidly fixed in the hull, and horizontal aiming is achieved not by turning a turret, which simply does not exist, but by turning the entire machine on its tracks. Vertical aiming is accomplished by changing the ground clearance. The hydro-pneumatic suspension raises or lowers the hull, lifting or lowering the barrel. The crew of this vehicle consists of just 3 men, and an automatic loader feeds shells into the breech without the participation of a loader. The power plant is dual. A gas turbine engine works in tandem with a diesel engine, which for the late 50s was a genuine technical revolution. Yet, for all the striking appearance of this machine, it has nothing to do with the real number 106.
This is a classic museum confusion, where 2 completely different pieces of equipment accidentally receive similar markings in different sources, and then this error spreads across the internet and becomes established as a reliable fact. The real tank under number 106 is an entirely different story. It was a machine that was supposed to appear on the basis of a British tank that had served in the Swedish Army for several decades, to receive a new suspension, an updated fire control system, and become the logical continuation of an entire lineup of modernizations. But between the design and its realization stood a chain of decisions that changed the fate of the Swedish armored vehicle program entirely. The project was stopped at the stage of papers and blueprints, and ever since, the tank exists only as a line in technical catalogues, surrounded by the conjectures of historians and armored vehicle enthusiasts.
To understand where this phantom machine actually came from, and why its fate unfolded the way it did, we need to go back several decades, to post-war Sweden, which was left with an outdated and miscellaneous fleet of armoured vehicles completely unsuited for the new era of superpower confrontation. Post-war Sweden found itself in a position familiar to many European countries of that era, but with one significant reservation. The country officially maintained neutrality and could not count on the direct military support of the blocs forming on either side of the new dividing line. The armoured fleet inherited by the army after the war consisted mainly of domestically designed pre-war and wartime machines. Light and medium tanks, designed back in the 30s and 40s, armed with 75mm guns and possessing bulletproof rather than armor-piercing protection. The armor thickness on most of these vehicles did not exceed 55mm even in the frontal projection, and the mass rarely exceeded 26 tons. Against the new medium and heavy tanks entering service in neighboring countries, such equipment could no longer be considered a serious force. The Royal Armament Administration understood the problem perfectly well. As early as the mid-50s, a competition was announced for a next-generation tank, a machine capable of replacing obsolete models and becoming the basis of the armoured forces for decades to come. One of Sweden's industrial consortia, uniting several of the country's manufacturing enterprises, proposed an ambitious project for a heavy tank with a 155mm gun mounted in an unusual, oscillating turret. The project looked promising on paper, but required colossal investments and time, which the Swedish army simply did not have. Too long a development meant that by the time the tank was adopted into service, it risked becoming obsolete even before leaving the factory gates. While engineers argued over the blueprints of the future Swedish tank, the army needed a solution here and now. The outdated fleet required immediate replacement, and the domestic heavy program promised to stretch out for years. And so, the eyes of the military leadership turned abroad, to where a proven, serial, and well-proven machine already existed, having participated in actual combat operations and proved its reliability in several theatres of war. We are talking about the British tank that was to become the backbone of Swedish armour for the next 40-plus years. And it was on its chassis, after decades of endless modernizations, that the very phantom project under number 106 would be born.
The choice fell on the British Centurion, a tank developed in the final years of the war, but which, thanks to its successful basic design, turned out to be exceptionally promising for further modernization. The first vehicles arriving in Sweden in the early 50s received the local designation Stridsvagn 81 and carried the English 76.5mm gun known as the 20-pounder gun, corresponding in design to the British Centurion Mark III variant. The crew of this machine consisted of 4 men: commander, gunner and loader in the turret, as well as the driver located in the front part of the hull. The combat weight of the vehicle reached 51 tons, which for the early 50s was a very impressive figure. The power plant consisted of the Rolls-Royce Meteor petrol engine, producing about 650 horsepower, essentially a distant relative of the Merlin aero engine that powered Spitfire fighters during the war. The Merritt-Brown transmission provided the machine with a speed of about 35 kilometers per hour on the highway and a cruising range of about 190 kilometers. Parameters modest by current standards, but quite sufficient for the defensive doctrine of the Swedish army, which did not imply deep offensive operations. In the late 50s, Sweden received another batch of improved machines designated as Stridsvagn 101. This was a modification of the Centurion Mark X, equipped with a much more powerful 100mm rifled gun known under the index L7. This gun subsequently became one of the most mass-produced tank guns of the Western Bloc and was installed on dozens of different tank models around the world. The ammunition load was about 64 rounds of separate loading placed in the hull and turret. The armor protection of the turret frontal projection exceeded 150 millimeters of rolled steel, making the machine resistant to most anti-tank assets of its time. Earlier vehicles armed with the outdated 20-pounder gun also did not remain neglected. During 1964 to 1966, they were rearmed with the same L7 gun and reclassified into Stridsvagn 102, bringing the entire fleet to a single weapon standard. By the mid-60s, the total number of British tanks in Swedish service, taking into account all modifications, exceeded 3,500 machines, making the Centurion the unalternative backbone of Swedish armoured forces for the next 4 decades. It would seem the question of the army's main battle tank was closed for years to come. But behind the facade of successful rearmament lay something far more complex. Sweden was entering an era when the very concept of neutrality required constant balancing between demonstrating strength and avoiding provocation. And the tank fleet was becoming not just a military tool, but part of a delicate diplomatic game between 2 superpowers. Officially, Sweden had maintained a neutral status since the Napoleonic Wars, and this tradition turned into the cornerstone of national identity. But behind the declarations of non-interference lay a far more tense reality.
The country was in close proximity to Soviet naval and air power in the Baltic, and its lengthy coastline and strategic position on the path of potential advancement through Scandinavia made Swedish territory potentially important for both sides of the confrontation. The military leadership understood perfectly well: neutrality is not free. It holds up precisely as long as it is unprofitable for an aggressor to violate it. From this understanding, an entire military doctrine was born, named total defense. Its essence was to make any invasion so costly and protracted that a potential adversary would abandon such an idea in advance. Tank battalions armed with Centurions were integrated into this very logic. Not offensive, but deterrent. The machines were placed along likely directions of a possible strike, ready to act from ambushes, use the natural relief of rocky Swedish terrain, and inflict maximum damage while remaining minimally vulnerable.
It was precisely this defensive philosophy that later pushed Swedish designers to create that very turretless tank without a traditional rotating turret mentioned earlier. A machine designed specifically for firing from entrenched positions, where a low hull profile height of just over 1.5 meters to the roof turned the tank into an extremely difficult target to detect. But while this unusual project was only being developed, the main burden of deterrence was borne precisely by the Centurions. Reliable, but by their nature, British machines designed for the requirements of an entirely different war. Balancing between demonstrating strength and avoiding escalation required Sweden to constantly update its equipment park without public disclosure of the scale of rearmament. Modernizations were carried out quietly, step by step, without loud statements. Armor was thickened, electronics were changed, but outwardly the tanks remained recognizable silhouettes of British origin for many years. Such covert, creeping modernization proved to be a convenient strategy for decades, but it had a serious flaw. It worked only as long as the basic design of the Centurion retained at least some technological margin of safety. And by the early 80s, this margin began to rapidly deplete, as Soviet armored vehicles made a qualitative leap that left Swedish tanks far behind in a whole range of key protection and firepower characteristics. By the early 80s, Soviet industry was producing a new generation of tanks equipped with combined armor, smoothbore 125mm guns, and automatic loaders that allowed reducing the crew to 3 men without loss of rate of fire. The armor penetration of new subcaliber shells reached figures against which the frontal armor of the Centurion, 152mm thick, looked like frankly inadequate protection. The gap in generations of equipment became obvious even without deep technical analysis. It was enough to compare the mass of active armor, the rate of fire of automatic loading systems, and the range of effective fire provided by the new fire control systems of a probable adversary. The Swedish military leadership realized the scale of the problem and launched an ambitious program to create a fundamentally new main battle tank, designated MBT-2000. The concept implied a machine with modern combined armor, a 120mm gun, and a new generation electronic fire control system, including a thermal imaging sight, a laser rangefinder, and a ballistic computer capable of automatically taking into account crosswind, propellant temperature, and barrel wear when calculating lead. The program promised to bring Swedish armored forces to a fundamentally different technological level, comparable to the best Western samples of that time. But reality turned out much harsher than ambitions. Developing a completely new tank required colossal financial investments spread over a good 10 years, and parallel to this, Swedish industry lacked experience in creating armor steels and composite materials at the level of the largest tank-building powers. The MBT-2000 project never advanced beyond the stage of a full-scale wooden mock-up, demonstrating only general layout solutions, but having neither a working power plant nor a working weapons system. Program financing was gradually reduced, Budget priorities shifted toward more pressing tasks, and the ambitious project of the new Swedish tank quietly faded without ever leaving the design bureaus. The failure of the program to create a completely new tank placed the Swedish military command before a highly unpleasant dilemma. There was no longer time for zero-from-scratch development, and the threat from the rapidly modernizing Soviet armored vehicle fleet had not gone anywhere. The only realistic way out remained what Sweden had already demonstrated more than once over the preceding decades: deep modernization of the existing Centurion fleet, bringing the outdated British foundation to the maximum possible technological limit by means of its own defense industry.
It was precisely this forced necessity that launched the program that would subsequently gift the world an entire family of modernized machines, and ultimately lead to the appearance of that very phantom tank under number 106. The modernization design was undertaken by Bofors, Sweden's oldest arms manufacturer, whose name was inextricably linked with the country's armored vehicle industry throughout the 20th century. The program received the official name REMO, an abbreviation of Swedish words meaning renovation and modification, and started in 1983, stretching for 4 years until 1987. The task facing the engineers was extremely specific: to breathe new life into the aging British hull without changing the basic layout of the machine radically, since a complete redesign would have cost almost as much as creating a new tank from scratch.
First of all, they tackled the fire control system, hopelessly outdated by the standards of the 80s. A laser rangefinder was installed, allowing distance to the target to be determined with an accuracy of a few meters instead of the gunner's previous visual distance estimation. A ballistic computer appeared, automatically calculating corrections for range and propellant temperature, which sharply increased the probability of hitting the target with the very first shot. The gun stabilizer received refinement, allowing targeted fire on the move with much greater precision than before. Night combat ceased to be the exclusive prerogative of the enemy. Night vision devices were installed on the tanks, although full thermal imaging sights still remained a rarity and appeared only on the most advanced modifications. An equally important change was protection. Blocks of explosive reactive armor, operating on a principle similar to the Israeli Blazer system, were installed on the frontal part of the hull and turret. Upon impact of a cumulative shell, the explosive substance inside the block detonated with a counter-explosion, destroying the cumulative jet even before it could burn through the main armor. This innovation became truly revolutionary for Swedish armored vehicles. Previously, such protection was simply not used on local tanks. A thermal shroud was added to the gun barrel to prevent uneven heating of the metal and the associated curvature of the shell's trajectory during intense firing. The exhaust system also changed, reducing the thermal signature of the machine for infrared enemy detection means. The power plant was also revised. A new, more powerful diesel engine was installed on some of the machines to replace the previous Rolls-Royce petrol engine, which not only increased power but significantly reduced the fire hazard of the machine in case of combat damage to the fuel system. The combat weight of the modernized tanks increased to 54 tons due to additional armor blocks and new equipment. But the mobility of the machine was preserved at an acceptable level thanks to the increased engine power. It was from this program that 2 new modifications were born, receiving the indices Stridsvagn 101R and Stridsvagn 102R. The letter R in the designation indicated precisely the fact of undergoing renovation and modification. These machines became noticeably closer to the technical level of Western counterparts than previous basic Centurions. But even such deep modernization did not put an end
to the history of the Swedish tank fleet.
Bofors engineers were already hatching the next, even more ambitious step, creating machines with a completely new suspension and updated electronics capable of serving for another good 10 years. And it is at this stage that the mysterious number 106 first surfaces in the documents. The next modernization step was conceived as something more than just installing new reactive armor blocks. Bofors engineers intended to completely revise the suspension of tanks brought to the R standard, to replace the previous torsion bar scheme with an improved system capable of withstanding the increased mass of the machine without losing smoothness of ride and without excessive wear of the road wheels. Additionally, a deep overhaul of the fire control system was planned, a new ballistic computer capable of processing data faster than before, and a refined laser rangefinder with increased measurement range, allowing targets to be engaged at distances inaccessible to the previous generation of electronics. From this concept, two parallel projects were born at once. The first, designated Stridsvagn 105, was developed on the basis of the already modernized Stridsvagn 102R tank. In addition to the new suspension, the machine received a redesigned driver's hatch with improved viewing devices. True, for this, part of the reactive armor blocks in this section of the hull had to be sacrificed, since the new hatch design physically left no place for their installation.
It was planned that this tank would be able to use the same ammunition as late versions of Stridsvagn 104, including the Israeli sub-caliber shell with a discarding sabot adopted into service by the Swedish Army in 1990. This shell provided noticeably higher armor penetration compared to standard ammunition of the previous generation, which was critically important against new samples of Soviet armor. The second project is that very tank under number 106, a modification conceived as a mirror development of the same idea, only on the basis of the Stridsvagn 101R tank instead of 102R. According to the engineer's design, the machine was to receive an identical new suspension and a similar updated fire control system, effectively becoming a technical twin of the neighboring project, but on a different initial platform.
The developers considered this machine as the logical conclusion of the entire lineup, bringing absolutely the entire remaining fleet of modernized Centurions, regardless of the initial modification, to a single new technical standard. The Stridsvagn 105 still managed to get its single prototype. The prototype was indeed built and tested, proving the viability of the new suspension and updated electronics in practice. But its sibling with number 106 was much less fortunate. The project existed only in the form of engineering documentation and calculations based on already confirmed solutions of the neighboring machine. But metal was never cut for it, and the prototype never left the walls of the design bureau. The reason lay not in technical failures and not in test failures. It lay in the much more prosaic plane of budget decisions and strategic priorities adopted by the country's military leadership literally in those same years.
The outcome of this story turned out much more prosaic than could be expected. While Bofors engineers were finalizing the blueprints of the new suspension and electronics for the 106 project, the Swedish military command was simultaneously negotiating a fundamentally different solution to the tank question. Not further modernization of aging British machines, but a full-scale purchase of a modern Western tank of a new generation. In 1991, the government officially launched a program called Stridsvagn Nu, within which 3 samples of foreign equipment were delivered to Swedish territory for comparative tests. An American tank with a 120mm gun and depleted uranium composite armor, a German improved version of the Leopard 2, and a prototype variant of a new generation French tank.
The tests took place in real Swedish conditions, on rocky cross-country terrain, at low temperatures characteristic of a Scandinavian winter, where parameters such as engine power-to-weight ratio and the ability of tracks to maintain grip on icy ground were especially important. The German machine demonstrated the best combination of protection, firepower, and power plant reliability. Its 120mm smoothbore gun, combined with modern multi-layer armor, exceeded the indicators of any of the modernizations available for the outdated British platform. Based on the test results, the choice fell precisely on the German tank, which in Swedish service received the designations Stridsvagn 121 and Stridsvagn 122, depending on the specific version and package. This decision put an end to several parallel programs at once.
The economic calculation turned out to be extremely simple and ruthless. Investing additional funds in the deep modernization of tanks, whose basic design dated back to the final years of the war, simply made no sense when the purchase of a fundamentally new, technologically superior sample was already on the way. Project 106, even without leaving the design stage, turned out to be economically unfeasible before it managed to prove any practical value at the test ground. Financing was curtailed, documentation was sent to the archive, and the few engineers who worked on the project switched to other tasks within the framework of the advancing rearmament of the army. Even the neighboring Project 105, despite the built and tested prototype, shared the same fate. Mass production was never launched, and the single prototype remained a museum exhibit, a reminder of what the final round of evolution of the Swedish Centurion could have become.
Project 106, in this sense, found itself in an even less enviable position. It did not even have the comforting status of a built prototype. It remained exclusively on paper, in the form of calculations and blueprints that were based on already confirmed solutions of the neighboring machine, but never turned into metal. Only the question remained open. What happened to the tanks themselves that were supposed to receive this unfulfilled modernization? And is there a chance to see them not in the form of blueprints, but at least as museum exhibits available for viewing today? The fate of real Centurions that served under the Swedish flag for over 4 decades turned out quite predictable, but no less symbolic. With the entry of German machines into service, old British tanks began to be systematically withdrawn from active units. The last units armed with the 104 modification continued service until the mid-90s on the island of Gotland, a strategically important point in the Baltic Sea, where tank presence retained significance until the very end of the program. But even here, the time of the British machine came to an end. By the year 2000, military reform finally excluded tank training from the Gotland Brigade's composition, and the last Centurions went for write-off. Part of the machines went for scrapping, parts settled in private collections and at military ranges as targets for testing new anti-tank weapons, and some specimens truly found their place in museum expositions, both in Sweden itself and beyond its borders, including the famous Tank Museum in Great Britain, whence the basic design itself originated.
It is there, among the preserved samples, that armored vehicle historians and enthusiasts continue to unravel the knot of confusion around designations. Which machine bears which index? Which modification corresponds to which year? And which of the projects actually existed in metal and which remained just a line in engineering documentation? The tank under number 106 remained the only reminder of what the final generation of the Swedish Centurion could have become if history had turned out differently. Not a single built sample, not a single surviving machine, not a single photograph of a real prototype. Only blueprints, calculations, and mentions in highly specialized catalogues that year after year retell the same story about a project that outpaced its own time by literally a few years and therefore never saw the light of day. This story once again reminds us, far from every tank that ended up in military archives actually went out onto the battlefield. Sometimes the most interesting pages of military equipment are stories about what could have happened, but did not happen. About machines that remained ghosts of their own blueprints. And such unrealized projects in the archives of various armies of the world are much more than it seems at first glance. If you are interested in such stories of forgotten and unrealized equipment, be sure to watch other videos of our channel. Links to them will appear right now on the screen. Do not switch, there is still a lot of interesting things ahead from the world of military technology.